Welcome back to the workshop. So, last time we left you, I'd got some of the logic sorted out. Made a few errors along the way, but we've got those corrected. And now I've just taken a little bit more time to wire up the complete master relay. So it's now got the latching function. We've now got the contactor working, and I'm about to throw the main switch, and we'll see if we can get these drives working. Alright, so first of all we'll throw the main breaker on the power supply, which is up here. We'll switch on at the wall, switch on here. Okay, you're probably too far away, but the little contactor will move across, and then we should get some power down to the drives. You should see those little lights come on. Alright, here we go. Yeah, it worked. So all the drives have come on. I can hear the stepper motors humming. Yeah, I'll probably better turn it off because I haven't got any step and direction signals connected, so just in case we have a problem. But yeah, that works. So if we turn this off, actually if we hit, oh yeah, let's try the E-stop. So if we hit E-stop, oops, panel's loose. Okay, it's thrown the switch and they've gone off, everything's gone off. Fabulous, right. We'll try that again, and then we'll try the machine E-stop. Everything's on. I'm just pressing the machine E-stop now. Okay, yeah, it's tripped out. It's gone. Okay, fabulous. Another step closer. Okay, so the next thing to do then is to get the spindle wired in. So these are the spindle start-stop, and they feed up to the spindle relay there. So we need to get all the wiring associated with that sorted out. And then we've basically got the same functionality as before. And yeah, what do we need to do next? Then we can finish off on the motion control system. Okay, so I've just wired in the spindle start-stop. I'm just tidying up all the cables. Now there is a proper tool you can get for these that sort of grabs the cable tie, pulls it, cuts it, and then it retracts back in because it's kind of stretched it before it's cut it, and it puts the cut edge inside. So I've always fancied buying one but never got around to it, because of course with these you always catch your skin on it. And if you're unlucky, it can cut you. Anyway, one day, let's just trim these all to length. Now you do have to be a bit careful with which cables you actually harness together. You can get electrical interference jumping between the cables, but these are all sort of low voltage stuff, just logic, so I think we'll be okay. Now I need a little bit of room just for them to be able to kind of swing, so when you lift this up you can see this sort of push inside and swing round. So I'm not going to make them any tighter than that. Right, just got the latch in there. So the last one we need on this one is just the spindle start-stop. So we've already got the top one in. And now we need this one, which is pin 10. Okay, so I mentioned this in the last video and it's come through, so we'll fit this in a moment, but just to give you a quick overview of what we got here. So this is my reset switch, so it's a momentary contact like that, so that makes a connection, then you let go and it breaks it. So this will be my reset. The nice thing about this one, it's got a little LED indicator on there, and it's a 24 volt. Now you can get all sorts. Oh, I'm being attacked by a bee or a wasp. Okay, in the last video I mentioned I had this on order. Right, it's finally come in. So this is my reset switch. So it's a momentary one, so you press it like that, makes contact, let go, breaks the contact, and it's got an LED on it. This one's a 24 volt. Now you can get a range of these. Some of them are 240 volt mains, so just be careful, make sure you get the right one, otherwise it won't light up properly. I'm going to run this on 24 volts, so I'll have 24 volts coming into the normally closed contacts on the contactor. So in the reset condition, when it's not active, those contacts will be closed. It'll feed 24 volts into here and the light will come on. And that's saying that the contactor's in an off, ready to go state. When I press this, which is the reset, the contacts will move across, everything will power up, we power up the drives, and that normally closed contact will break and the light should go out. So it's a nice way to check that the contactor's doing what you think it's doing and it's all functioning correctly. So that's the plan. Just to show that in a bit more detail. So I've got 24 volts hooked up here, so we'll put that on there. That on that side. It looks a bit yellow on camera, but it's a very red colour while I'm looking at it. I'm not sure it matters about polarity. Let's just check that. No, it doesn't matter. Okay, so you can wire it either way around. And then the last thing just to check is, so we've got a pair of, we've got both on this. Okay, so we've got some normally closed and normally open. So I think 12 and 11. 50-50, got the wrong one. Okay, so they're normally closed. Okay, fine. So that's the one we want for the, no, we want this one for the reset, normally open. Okay, so we'll get that wired in. Just to show you the modular nature of these, they've all got slightly different varieties of how they fit at the top, but if we lift that up, pull it across, you can take the main sort of switch bit at the top off. Next layer down is the illuminated part and the contacts, and then you can kind of see from there as a little clip-on mechanism. So you get these kind of universal pieces that you can put on the bottom, interchangeable with different functions, and you can stack them up reasonably high. I mean, 2, maybe 3, then the effort loads get a bit high, but that's the kind of idea. It's quite modular and I quite like using these. So let's put that back together and we'll get that fitted. Now you might remember in the last video I was just talking about these labels, and in fact I was printing on these labels, and I'd looked around for a kind of tubes type solution that goes around the cable and found them to be very expensive. However, I had a brilliant comment. We'll come back to that in a minute. So thank you very much for that comment. Basically just suggested just have a look around AliExpress or wherever, and you can buy them relatively inexpensively. So this kind of ribbon cable I had been using, which was this, which sort of bends round corners, and then I could put some clear heat shrink over the top. That was working fine. Went into the label maker like that, and then you printed it. As you can see, I found this heat shrink tube. Thank you very much for that comment. I think you could buy it for about £6 from China or £8 from the UK. So I went with the UK reseller, and it's kind of a tube that it prints the label on. So I've just made one up, and it comes out like this, like that, and it's can't open it up now, but yeah, there you go. So this is 6mm. You get a range of sizes. I think it's maybe about the smallest they do. Maybe there's one more, can't quite remember. It goes all that sort of 18 or 24. So there's all sorts of sizes. Print on whatever you want, and they just heat shrink it direct. So thank you very much for that comment. That was really helpful. Now, the second thing to say about that is, I don't know what's up with YouTube at the moment, but every now and again I get a notification of a comment, and I like to reply. You know, I don't get that many on my channel, so I like to reply to each one. But sometimes you get a notification, but when you click to press reply, there's just nothing there to reply to. I just can't send a reply, and every now and again that happens. And I did a search around Google just to see if it was a common experience, and yeah, you know, I'm not alone. There's thousands, tens of thousands of people with the same kind of problem. It doesn't look like YouTube have fixed it or about to fix it anytime soon. So if I don't reply to you, it's because I can't see it and I can't actually hit reply. So I'll say the reply in this video, which is thank you very much for suggesting. There are some kind of cheap versions of this, and they work absolutely fine so far. Yeah, I've just tried one and it worked really well. So if I don't reply, it's because YouTube's messing me around. So sorry about that, and thanks again for the comment. Pretty pleased with that, looks good. It's a bit quicker than the other method, putting the label on then putting the clear heat shrink over. Nice. So that switch I just showed a few minutes ago, we got that connected, and we got the wire in there that runs the 24 volt LED. So that comes from the normally closed contactors on the main contactor. So when that's off, that'll allow power to flow through, come through here and light the bulb, and then when you press reset, the contactor engages and the light should go out. That way you know the contactor's working. And then we've got the two terminals at the normally open ones for the momentary. So that should all work. And then over here we've got wired up the start-stop for the main spindle, so we'll have a look at that and see if we can get that to work as well. Right, so let's button this up and give it a try and make sure that bit's working. Again, like before, we'll just temporarily put that in there. Okay, control in first, and then VFD. Okay, that's running nicely. Let's switch on the panel, reset. And the drivers come on, relays clicked, master relays on. Okay. So if this works, you'll hear a kind of rubbing sound as it fires up. Let's try it again. Didn't have the potentiometer set very high. Okay, fire it up. Let's talk a little bit about relays again. So we had some really good feedback from the last video, so thank you very much for that on relays and ways to wire them, particularly the best polarity to use and using the flyback diodes. Now, just to make this clear, I do normally wire them up the way so that when they're on, the LED comes on, and then I have some kind of flyback diode in there just to suppress the little spark you get. So normally I'd have them like this. Oh. So 0 would be on my 13, positive would be on the 14, and when it's activated, as you can see, hopefully you can see there, the light comes on, and then when you turn it off, light goes out. So that's normally how I would do it. And then I'd have some kind of diode like this. So this is general purpose, it's a 1N series, so 1N 0001, 2, 3, 4, whichever, for the different voltage ratings. And as you can see, this is the problem I've always come up against. It always gets a little bit awkward to try and wire something in. As you can see, this is an old project. I've tried to sort of tee off the back of two connectors and try and get two into one. You end up, because you've got power going to here and because you've got a latching function that also has to come back to here, you end up with, and then you want to put these across 13, 14, you end up with it being quite congested and awkward, and then you sometimes have to have this sort of remotely on something. I never really found a great way to do it, a neat way. I mean, they always work, but a neat way to do it. So when I came across this being wired the other way, I thought, oh, maybe that's a better way. But thanks to all your comments and suggestions and me just thinking about it, that clearly isn't. You're going to put 24 volts through the LED the wrong way. Really, you can go up to about 5 volts the other way, as people have pointed out. So we're back to wiring it up as we normally do. And when we go over to the control cabinet, I'll show you my latest sort of neatest idea that I think I'm going to use with this to give me a bit more freedom on where I put all my cables and so on. But thank you very much for your comments. So I think it's back to business as usual with this. I'll just give you a quick shot of the spindle relay and the master relay there. I ended up breaking it out using these, the blue and the brown terminals there. They're the Dinkle 2.5, just to help with the wiring, because there's so many little connections you need to make. And then what I'm planning to do is just at the top there, between that spare blue and brown, we'll join those together with the diode. That'll be the flyback diode for the master one, and then again I'll put a diode across there in those two spare terminals for the flyback for the spindle. Now, I was looking through my diode collection, and I've used them all up, so I've got nothing left. So I've just got some on order. When they come through, I'll drop them in there, and then you can just see those in a future video. Right, let's get this thing wired up, and we'll get some step and direction down to the stepper drivers. Okay, so many hours later, it's amazing how long this wiring all takes. We've got the two X, the Y looms made up and wired in, and I've just finally made the two Z looms, and as you'll see there, I've paired up the step and direction for each one, so we've got one signal going into the two feeds for each one, because we've only got so many channels on there. We can only run 4 stepper drivers, and I've actually got 5 here. Now, as I said in the previous video, we can pull up to 20 milliamps from one of these terminals, and we're pulling between 5 and 10 from each of these, so we should be okay. And I've confirmed that with the supplier, but you know, we'll see how we get on. And if we have any problems, we'll have to make use of this port here and have an extra board. But let's see if we can get this to work. So let's wire these last ones in, and we should have our steppers done. It's going to be a little bit fiddly. I'll start with the, let's do the blue, yeah, the step. Okay, and then step. Okay, make sure they're nice and tight, but not too tight. Okay, that's got it. Right, this one should be a bit easier. That's our 5 volts. So you basically just push these in until you can feel they've hit the screw. Yeah, when you want, then back the screw out and suddenly go in and then bring it back down. One. Two. And then all it remains is just to plug them in. And the last bit here is the network cable. Okay. Let's make sure these are routed where they want to go. Good step forward. Wow, that took forever. Well, we finally got there. That was a shed load of wiring. I said shed load. I said shed load. Right, so we finished up the main power distribution. We've got the reset working, the emergency stop, we've got the auxiliaries working, and we've got the manual stop start for the spindle working. Also got quite a lot of the wiring done on the AXBB units. We've got the Ethernet, we've got the step and directions for all the different stepper drivers, and we've got the 5 and the 24 volts, so we've got the basics running. And then we've also got the spindle working, so we've got the latch function on both those, and we've wired it up, the traditional proper way. Only thing I've got to do is just put the flyback diodes in the spare terminals at the top for both those, and then that will be complete. Got all the step and directions finished down here. We already had the power ones, we made those in the last episode, and the stepper ones, which are these ones down the bottom, I already had those from before, so they were just the same. And as you can probably see down here, I've borrowed some of the blue and the brown terminals there just to get the relay system working. So I've ordered some more of those in, they'll be in pretty soon. And then what we can do is finish off by putting the proximity sensors in there. So we've got all our homes and limits, so they'll all come into here, be grouped together for the 24 volts and the 0 volts. And then just the signals for each one will go up to here and into the input terminals at the top there of the Ethernet system, and then it will know where it's at when it's at home, and it will know when you've tripped over to a limit. And then we need to start getting the PC working. So you see I've got the keyboard and mouse ready, got the Ethernet cable, I'll go run that down the back. We've got the USB cable as well that comes from this front panel, goes back into the back of the machine. And down here we've got this new to me, PC tower. So we need to talk a little bit about that and the hardware requirements to run the UCCNC software, but we'll get into that next time. Okay, thank you very much for watching. Thank you again for your comments, really appreciate it. It's really nice to hear what you have to say, and it's really helping me out. And I think all that remains to be said is thanks for watching, and see you next time.